Hello everyone. Today we will present our topic microscopic imaging of blood flow and oxygenation. So first let me briefly introduce our background. So cerebral blood flow is the movement of blood through the blood vessel in brain. So why monitoring CBF is important? So because CBF is a critical component of brain function, it supplies the brain with oxygen and nutrients necessary for brain function. And the abnormal of CBF can lead to various neurological disorders such as stroke and dementia like Alzheimer's disease. So measuring CBF is important to diagnose disorder and can be done using image technique like MRI and PET. The second thing is brain oxygenation. So the brain has a high metabolic demand and requires a constant supply of oxygen to maintain its function. So measuring oxygenation in brain can provide valuable information about the health of brain and can help diagnose the disorder. So usually they have a lot of like technique to visualize and measure the movement of blood cells and amount of oxygen, but there are two common methods in confocal laser scanning microscopy and two-photon microscopy. So first, let me introduce the optical coherence tomography, OCT. So there is two components in OCT, angiography and blood flow measurements. So the principle of angiography is based on the scattering of light as it travels through the blood vessel in the brain, and OCT uses the light to create detailed image of brain and measure the reflection and scattering of light as it travels through the tissue and blood vessel. OCT can also use to measure the blood flow by analyzing the movement of blood cells in the vessel. This is typically done by tracking the movement of the contrast agent with the fluorescence as it follows through the blood vessel. So in an OCT system, the scatter light can be measured using the detector, which is a photodiode and spectrometer. The photodiode measure the intensity and direction of the light. The intensity of the scatter light is measured of like amount of light that is scattered by the tissue, and the direction of the scatter light is measured of the angle which is the light is scattered by the brain tissue. And the second method is two-photon oxygen imaging. Two-photon oxygen imaging is a technique used to measure oxygen level in biological tissue. It involves shining a laser beam at the tissue and measuring amount of light that is absorbed at two different wavelengths. The difference in the amount of light absorbed at the two different wavelengths can be used to calculate the amount of oxygen present in the tissue. And there are two common methods to perform. The first one is use a pulse modulated laser that emit light at two different wavelengths. And the second is use a continuous wavelength and to modulate intensity of light, we use the interferometer, which I will explain to it later. So one photon or two photon excitation is better. I think it depends on the specific situation. And usually, in general, two photons excitation can be more efficient and result in less photo damage to sample being studied. However, one photon excitation may be more convenient in some situation. So it really depends on the purpose. And some disadvantage of two-photon oxygen imaging, it requires expensive equipment, and the technique can only apply to living tissue, but no for non-biology sample. And next, my teammate will present the last method, photoacoustic imaging.
Thank you, Minh. My name is Phuong, and let me continue our presentation. First, I want to tell you what is photoacoustic imaging. It is a medical imaging technique that combines the principle of optical absorption and acoustic detection to produce high-resolution images of tissues and organs. In PAI, the power of the laser light is shown to the tissue being studied, and the result absorption of light by the tissue generate a very small but detectable thermal expansion or a pressure wave. This pressure wave can be detected using a sensitive microphone or other acoustic detection, and the resulting signal can be used to create image of the tissue. One common method to use a power laser with a wavelength that is absorbed by the tissue being studied, such as near-infrared light. The laser power is focused on a small spot on the tissue, and the result absorption of light generates a pressure wave that is detected using microphone or other acoustic detector, and the location and amplitude of the pressure wave can be used to create an image of tissue. And both two-photon imaging and photoacoustic imaging, we mentioned a lot about interferometer. And if in this slide, I will briefly explain interferometer to you. It is a device that uses the principle of interference to modulate the intensity of light. It typically consists of a beam splitter, which divides the light into two separate parts. One light is used as a reference. The two light beams are then combined using beam splitter, and the resulting interference pattern can be used to modulate the intensity of light. In conclusion, all of them are powerful techniques for measurement of blood flow and the oxygenation in tissue, but they have different strengths and limitations. The OTC is highly sensitive and can provide detailed images of blood flow and oxygenation, but it is limited in its ability to penetrate deep tissue. And in another hand, photoacoustic imaging is less sensitive, but it can provide good contrast and high resolution, and it is able to penetrate deeper into tissue. Therefore, the choice between these techniques depend on the specific application and design trade-off between sensitivity and penetration depth. This brings me to the end of our presentation. Thank you for listening.